good morning, welcome back. So with respect to our last class, we have come across with the things like reviews, inspection. What do you mean by the term called out as review? So what's a process for a review? So there are three different phases which are included across. That's a uh, pre-review with the review meeting and the post-review activities there. Okay. So followed out with that, we had come across with around 6 different checklists which are being considered as your inspection checklist there. Okay. So followed out with that, let us come across with the next particular section here, that's called out as software measurement there. Okay. So what is a software measurement? It is concerned with deriving a numeric value for an attribute of a software product or a process there. Okay. So this allows for ultimately objective comparisons between techniques and processes what are included there. Okay. It is something like you must have come across, like for example, when a software has been measured. Okay, so software, if at all I am taking it across as a distance measurement or something, we say centimeter, meters, kilometers. Okay, so like this, how a software has been measured here. Okay, a software has been measured with different things to be kept into consideration, or else the standards which are kept into consideration there. Okay, so those will come across here with the two kinds of attributes. One is called out as external attributes and one more is called out as internal attributes. Okay, so if I am speaking about these measurements, okay, so how it goes across is, so here you can just come across, that's a software process. Okay, after this software process, I have a control metric measurements there. Then I have management decisions. Okay, whatever will be looked across. Okay, so when I am going through a software process, I have a software product with me. Okay, when I have a software product with me, so there are predictor metric measurements there. Okay, so through these metric measurements, so these will lead, or else these will make a lot of changes across with the management decisions there. Okay, so these management decisions, whatever are affected, will be affected directly to the software process what is included. If any changes with this management decision, ultimately that will affect the software process there. Then ultimately through the control metric measurements there. Okay, so this is with your predictor and control measurements there. Okay, so followed it with that, as I spoke just now, with the two kinds of attributes. One is called out as external attribute and one more is called out as internal attributes. Okay, so if I am speaking across with external quality attributes, so there are few attributes which are kept into consideration. One is maintainability, reliability, reusability, and one more is usability. Okay, so if I am speaking about internal attributes, so it goes accordingly as depth of inheritance, whatever you are using there. Okay, inheritance, that is ultimately which is binding across the classes to one another. Okay, then cyclomatic complexity, then program size in lines of codes there, then number of error messages, then length of the user manual. Okay, so these are all your internal attributes, and where I have my external attributes are these respective things there. Okay, maintainability is how best I am maintaining across with the product. So this leads towards the depth of inheritance tree, cyclomatic complexity, and length of the user manual. Okay, if I am speaking about reliability, the reliability indeed has a relationship with the cyclomatic complexity, else it can be the program size and lines of the code. Okay, else it can be the number of error messages which have been dealt out. Okay, reusability are with how much depth of inheritance I have, so that well I can reuse the things in a proper way. Else it can be the program size and lines of codes there. Okay, so I can make use of that into reusability. Okay, one more is the last one happens to be usability, that ultimately is directly proportional to number of error messages and length of user manual there. Okay, so this is the relationship between internal and external software. Okay, if I am speaking about my product matrix, okay, a quality matrix should be a predictor of product quality. Okay, so ultimately the classes of product metrics are dynamic metrics and one more is static metrics. Okay, what are dynamic metrics now? So that is nothing but which is made up of a program during the execution there. Okay, so those are the measurements which are being collected during the execution of a particular software. Okay, else it can be one more static, which are collected by the system's representation there. Okay, so dynamic metrics ultimately helps you in assessing efficiency and reliability of a product, whereas static metric helps you assess the complexity, then it can be understandability and maintainability. Okay, ultimately these metrics help you in determining across with external and internal attributes there. Okay, so the same related I am speaking across with dynamic metrics, which says that they are closely related to software quality attribute, whereas static metrics have an indirect relationship with quality attributes there. Okay, so these are directly closely related because during the execution it is. Okay, whereas it is with indirect relationship. Okay, so if I am speaking about static product attributes there, so these are few of the things which are being considered. One is fan in, fan out. Okay, so that is nothing but which tells you regarding how many a function is being called in another function. So that is ultimately I call it as a number of functions or method which has been called by another function or a method, so that is called out as fan in. Okay, so fan out is nothing but is the number of functions that are called by the function x then. Okay, so a high value of fan in means that x is highly coupled, tightly coupled there. Okay, so these things lead you or else tell you regarding the durability or as maintainability of a particular product. Okay, length of the code is nothing but this is a measure of the size of a program. So usually we judge a particular program based on the length of the code. The larger the size of the code of a component, the more complex ultimately. Okay, so as far as possible, of course, if at all there is no other alternative, we can go across. But if at all that's the case, so what we can do is we can shorten it as far as possible. The more complex and error prone that component is likely to be. Okay, length of the code has been shown, okay, in one of the most reliable metrics for predicting error proneness in components there. Okay, then we have cyclomatic complexity, that is the measure of the control complexity of a program. Okay, it might be related to the program understandability. Okay, then length of identifiers are there. Identifiers are nothing but the names of the variables, class, methods, whatever you are considering. The longer the identifiers, ultimately more likely it is meaningful, okay, to identify those variables there. Okay, so then comes is depth of conditional nesting, so wherein I have if, nested ifs there. Okay, as far as possible try to avoid it so that I can have an reduced complexity with my respective code there. And the last one is the fog index. So fog index is nothing but the average length of the words and the sentences which are used in documents. The higher the value of the documents fog index, the more difficult the document is to understand. Okay, so then we are coming across with the next categorization, that is object-oriented metrics, else I can call it as a dynamic metrics there. What are those? Weighted methods per class. So weighted methods per class is nothing but the number of methods which are being declared and defined in a particular class. So that is the number of methods in each class that is weighted by the complexity of each method. Okay, a simple method may have a complexity of 1 and large and complex method have much more value, that higher value. Okay, depth of inheritance tree. So that is when I speak about object oriented, inheritance has to come. So inheritance is nothing but where a class is being derived from another superclass. Okay, where we have a relationship called out as a superclass and a subclass. So I call it across as a depth of inheritance tree there. Okay, so how best, if at all, as we always know that multiple inheritance has to be avoided as far as possible. Similarly, if I have some more than a single level inheritance, if I have a high level inheritance with some 2 or 3 classes into one another, so at that time try to avoid it as far as possible there, so that that inheritance whatever is maintained, so that can be derived properly and used properly. Okay, and one more is number of children. Number of children is nothing but in this case number of subclasses which is being inherited by a respective superclass through a superclass. Okay, it is nothing but it measures the breadth of the class hierarchy. Okay, so whereas your DIT measures the depth here, okay, whereas NOC measures you the breadth of that particular things. Okay, then one more is coupling between the object classes. Just now I said you when the classes are being connected across with one another. Okay, so I speak about the coupling happens to be high, the coupling happens to be low. Okay, so coupling between the object classes here. When one method in one class uses methods or instance variables defined in a different class. Okay, so that is regarding your classes, coupling between the object classes. Okay, response for a class. So response for a class is nothing but RFC is a measure of the number of methods that could potentially be executed in response to a message received by an object of that class. Okay, so what responses are we getting? Okay, so it is ultimately related to the complexity there. Okay, so that is higher the value of RFC, then more complex is your respective class what I am using there. Okay, and the last one happens to be lack of cohesion in the methods. Cohesion is nothing but coupling here. Okay, cohesion, it is calculated by considering pairs of methods in a class. Okay, lack of cohesion in methods is the difference between the number of method pairs without shared attributes and the number of method pairs with shared attributes. Okay, so that is which defines you regarding the cohesion methods. I speak about the coupling which exists between the attributes which are lying across in a particular class whenever it has been defined along with the method there. Okay, so this is all with respect to your metrics or software measurement there. Okay, so this ultimately completes across with this particular section. Okay, so if any doubts or other things are there, okay, we'll have an interaction class and we can refer to the same there. Okay, I hope so you got across to know with the things there. Okay, thank you.